Good morning. So today, let's see how you can perform an HTTP call. So we will start with a simple HTTP request, which is a GET request. So here I'm on openweathermap.org. They are exposing a free API, and you can see that this is an endpoint that they are providing, a GET endpoint. You can see the URL, and you have the query parameter. It's just giving, if you're giving a city, they are just giving you some data about the weather. So let's start to code. So you've got your main function here, and we will just use the HTTP built-in Go package. So you just do HTTP dot, and you can see that they are giving you a get method, which will just perform get requests basically. So here I just copy paste the URL from OpenWeatherMap. So the city is London, and we need an API key. So the API key that you can see here, it's just a test API key from the account I created, so it will be invalid after the video. So don't worry, but you can subscribe and get yours, no worries. So the HTTP get method is returning a response and an error. So classic pattern that you know now, if the error is not nil, we're gonna log and panic. Otherwise, we can have a look to the response. So it's an HTTP response, so we can just inspect the status code. And you can see that we have an error back, unsupported protocol scheme. Protocol scheme is either HTTP or either HTTPS. So here we just added HTTP, and then it went back with a status code 200, which is an OK status code. So all good. So let's inspect the body. As you can see, it's not really readable. That's a bunch of pointers, false nil, and other pointers. So let's see how we can read that response.body. So we can use IO util with read all, because if we inspect the body, you can see that it's an IO read closure. And if we dive in, it's just an interface which is composing the reader interface and the writer interface. So we can use read all. So then we send response.body, and read all is returning bytes and an error. So you know the drill. We're just gonna panic and log if there's any error while reading the response body. And if all good, we can just have a look to the bytes. So here I'm using the string function because otherwise you would see an array of bytes, which is not super helpful. And there you go. You have the JSON response, and you can see that it's what expected from the API documentation. So success. Alright, here you can see that the temperature are in Fahrenheit. It's because the default parameter is standards. So let's just use the metric units. So you can just do ampersand and then units, and then we can use metric. And then if we run that again, it should be in Celsius degrees. So there you go, 12 degrees. 13, 12. All good. What's worth mentioning here, it's important to close the body, because otherwise you could lock resources that your program might need further on. So here we can just use body.close, because you remember that response body is complying to a reader-writer interface, so the close method is implemented. Here I'm using a defer, so then defer will be executed at the end of this routine being the main function. Have a look to the defer video if you don't know what defer is doing. There we run it again and all good. Okay, so let's parse this object from the JSON to have a proper data structure, so then later on we can do more interesting things. So here I need a struct to mimic the structure of the JSON response. So let's start step by step with the name London. So we can build a struct called weather response struct, which has the field name, and then using JSON tag JSON name. So if you don't remember this part, have a look to the video dedicated to JSON and marshalling. But basically here we just declare a variable of the type weather response, and then we will just invoke the JSON.unmarshal method from the inbuilt JSON package. So then unmarshal is taking bytes first, and then a pointer from the structure you want to unmarshal to. So this method is just spitting back an error if something went wrong, so you know the drill. We just check if it's not nil, otherwise panic and log. And then we can just print our the struct which is coming back, the weather response. Okay, so let's launch that one, and then you can see the last log line, which is London. Bonus, you can do a plus, so then you have the name of the field. Have a look to the hello world video if you've missed that one, missed that trick. And all good, name London, name London. So now let's parse this main field, which contains temperature. So we just extend our weather response basically. So main, and then we define main struct and the JSON tag main, and then we build that main struct. So here we want to parse all the temperatures, so then they're gonna be float 64. Maybe 64 is unnecessary, 32 or 16 would be necessary, but that doesn't really matter. Then we just copy paste the proper field name to the JSON tags, and then we rename properly the properties of this main struct. So we can have, for instance, temp feels like, and then temp min and temp max. Okay, all good. Let's try that one. And there you go. We've parsed successfully the temperatures. So here you can see how in a simple way we can perform a get HTTP request simply with Go, and then how we parsed the response to reach data structure. So then afterwards we can do meaningful transformation with them. If you don't remember or you're not clear about how the HTTP protocol works, I'm putting some useful links in the description. I'm also putting the HTTP package Go inbuilt library in the description to help you. Next step is to see how to perform post requests, and then moving forward we will see how we can build a CLI from those weather data. Hope you found it interesting. Thanks for watching, and happy coding.